Okay, so 6 and 7. Jeff's employee benefits include individual health care coverage. He contributes 25% of the cost. If he gets paid semi-monthly, and $67.70 is taken out of each paycheck, how much does his employer contribute annually for the coverage? I like how that part of that question is asked. It lets us know we want to know exactly. Before it was just total. We had to figure out what that meant. Now we know. So Jeff's employee benefits include health care coverage, and he contributes 25% of the cost. If he gets paid semi-monthly and $67.70 is taken out of each paycheck, how much does his employer contribute annually for the coverage? Well, we're going to have to take the total and subtract Jeff's cost, and that's going to equal his employer's cost. Does that make sense, Layla? Okay. So we can go ahead and figure out how much Jeff's cost is per year. We know every paycheck, they take out $67.70. How many paychecks does Jeff get in a year? So this is there's a biweekly is 26. So there's 52 weeks in a year. Every 2 weeks means he gets paid 26 times. Semi-monthly, 2 times in a month. There's 12 months in a year, so it's 2 times 12, which is 24. All right, so $67.70 times 24 is going to equal what Jeff pays. Does that make sense? Total. Total minus Jeff equals his employer contribution. So Jeff pays $1,624.80 per year. But that's only 25%, right? So there's a couple ways to do that. The rest of it, I said subtract it here. But looking at it, there's an easier way to do it. Jeff? What'd you divide it by? Yep, that is one way to do it. So let's do it that way. Let's say that 25% of the annual coverage for the year equals 1624.8. That's Jeff's contribution. If you take that and you divide it by 0.25, you will get the employer contribution. I'm not sorry, you will get the total. And that's $6,499.20. So you're going to take that $6,499.20 and subtract 1624.80. Yeah. So now we subtract. So to total, $64.99.20 minus Jeff's contribution, $1624.8 equals his employer's contribution. Should be $4,874.40. Another way to do it is he pays 1/4, right? So that means his employer pays 3/4. So you could just multiply Jeff's by 3 because the 25% is an easy number to work with, right? 18%, that wouldn't work because there's not an easy fraction to work with there. But, Layla, Madeline, 6 makes sense?
Yes. That's good. But
okay, my third here. The biggest thing to remember about this Social Security and Medicare is that sometimes the Social Security, the Social Security has a maximum taxable income. If they talk about that, and they do here, they don't say it, they don't label it maximum taxable income. You have to be able to find that in this problem. Social Security tax is maxed out by a maximum total income. So Dr. Grumman got his first job in 1991. In that year, Social Security tax was 6.2% of income up to $53,400. So this is the maximum income, total income. So if he makes more than $53,400, he still only pays Social Security tax on that amount, right? But anything less than that, you take his income and you multiply it by 6.2%. Medicare, remember, is never limited, so it's always 1.45% of whatever they make. So we look here, and Dr. Grumman earned $41,340. That's less than the maximum taxable income, so we don't have to worry about that. So we can take his Social Security percent and his Medicare percent and add them together, or we could just find his tax separately, which I think I'm going to do. So the Social Security tax would be $41,340 times 6.2%, or remember that's 0.062. His Medicare tax would be $41,340 times 1.45%. And then it says how much did he pay for both taxes? You just add them together. And it should be $3,162.51. I just added them all together on my calculator. If you want them separate, well, you could do them if you want them separate, but I'll do it. 2563.08. You're struggling using a calculator. Yeah, $599.43. And if you add those together, that's the total they pay. Any other questions on this worksheet? So if you didn't do the worksheet and you're copying things down now, remember you should always go back and try to rework them on your own, otherwise you don't get the full value of the assignment. Anybody any questions on anything else? Let me get a question on, no questions on the vacation day, if that makes sense to y'all? Layla? 8? I just had to break it down. Good. After we do number 8, we're going to do next. Layla asked for 8. So in 1998, Lisa earned $149,461.20. In that year, Social Security tax was 6.2% of income up to $68,400, and Medicare tax is 1.45%. How much did she pay for both taxes? Well, this is the maximum taxable income for Social Security only. This is a maximum taxable income. You have to know. It tells you up here, but when you see this phrase, that has to be your reminder. Oh, yeah, they don't pay 6.2% of what they make. They pay 6.2% of the maximum taxable income. So the Social Security tax has a maximum amount. So it's going to be 68,400 times 6.2%. But the Medicare tax does not have a limit, right, Layla? So then you take her income, the 149,461.20, and multiply that by the 1.45%. And then once you get those, you add them together, and I'm not going to do that part. Okay? All right, we're going to go ahead and get started then. Last section before we start our review, we're going to talk about functions. Functions are really just a different way to write an equation. Kind of like when we use formulas, we use an equation to solve for a particular variable. If we're looking for distance, we're going to use the formula distance equals rate times time. If we're looking for time, time is a function of the distance and the rate, right? So when we solve that, well, remember in algebra, we're going to call the literal equation. When we solve that, distance equals rate times time for t. So it would be t equals the distance divided by the rate, right? For finance, we really are talking mostly, our outcome is almost always money. Not always, but very often money. And our outcome, how much money we pay, how much money we earn, those sorts of things are a function of some other variable. Right? So our input to get us our output. So we always want, we'll almost always use a formula in that form. So in algebra, we learned that very often in business or real world, we use an equation. It's in slope-intercept form, y equals mx plus b. And in function notation, we replace that y with f of x, where x is the variable, right? X is the input here, x is the input there. But function notation means we label it and exchange the y for the function of the input, in this case, because the input is x, the function of x. So a function is a relationship where each input has only one output value. When you cover this in algebra, we talk about a vertical line test. If you have points plotted on a graph, you drag a vertical line over it. If that line ever crosses 2 points at the same time, we'll know that that graph represents some sort of relationship where there's two x's that have the same output, right? So we never want an input to have two different outputs if it's a function. So for example here, if f of x is x squared, it's a function. And it is a function because no matter what the value of x is, x squared has only one value. So if we plug in 3, if our input here is 3, and we square it, well then we get none, right? No matter how many times we plug 3 into this function, it's always going to be none. If we plug in -3, well, -3 squared is 9. Now, it's okay for the output to repeat. It's not okay for the input to repeat, right? If we get -3, or +3, 9, and +3, 27, then that can't be a function, okay? If we use f of -3 equals -3 squared, if we plug in an input of 5, that just means we're replacing the x with 5. So when you use function notation, you're writing everything in terms of what happens when you replace that variable with an actual value, right? What happens, what kind of our output change. Okay. So here we're not writing them in the same order, but what this next function says that is if f of x squared, so if the output is squared, what is our x? So if we take an input, if we take 9, so we take it and our x squared, what did we plug in to get that? Well, we could have plugged in a -3, right? But if our output squared is +9, we also could have had an input of +3. Does that make sense? So now we have an input value that has an output of 9, or the squared output of -3, or 3. So you would not necessarily get the same. You have two. I think it makes more sense when you talk about it as a square root. So the square root of 9 could be 3 or -3, right? So if I were to say, I don't want that example, but anyway, -3 or 3 are two different outputs for that square root of 9. That's what we're saying. We're taking the square root there. I'm going to work on that for next year. I don't like that. But we are not really going to have to determine if it's a function or not a function this year. I'm just reviewing it a little bit. We really are concentrating on the fact that anytime you're talking about money, if you tell me if I have 5 runs and an ad and it's going to cost me $25, if I get 5 runs and an ad, every time it should cost $25, right? So we're working with functions. It should not change. Another good analogy for a function is a vending machine. If you want a Mountain Dew and you see it says A3 on it, every time you press A3, you should get a Mountain Dew, right? So your input should always should only be one output for that input. If I put A3, it shouldn't be a question whether I get a Mountain Dew or a Diet Coke, right? Those are not the same, right? So if I press a button, A3, I should get the same thing every time. I should get a Mountain Dew every time, right? If I put 3 in this function, every time I square it, I should get a 9, right? Now, it's okay to have an equation that's not a function. When we're talking about functions, that's what we mean, okay? All right, and this is kind of the stuff we talked about already, but function notation is a way to express that equation with how does the input get transformed to get the output. When we see this function, this is read f of x equals x plus 5. Dynamic. Hold on. There we go. F of x is the output. Remember, in slope intercept form, that would have been the y, right? What do we get when we plug in a value for x? When we say x plus 5, we should know that is x is the input, and x plus 5 is the rule. That's what we're doing to x every time. So if you're asked to write a rule, you're writing what do we do to the input to get the output. Now, when you see f of x, you almost always see a function written as f of x. Unless you have more than one function that you're referring to in the same scenario. And then f is really just a label. We could say f of x equals x plus 5, and then we could say g of x equals x minus 2. So it's just a different way, it's a way to kind of separate two different rules, right, in the same situation. So f is just the name of this function. X is the input, and that's the variable we chose to use there. But remember this next little bullet point says you could use a different variable, right? So we could have f of t equals t plus 5. And basically that's the same thing. Maybe f of t is the cost. The cost is a function of the price, right? Or vice versa. Maybe the cost is the price is a function of the cost, whatever. But those they have the same rules, just a different variable. This one says that output is represented as f of x, which is red. We were talking about that. And the most common letter to define a function is f, so any could be used. So we could also write g of x equals x plus 5. Same rule, doing the same thing to our input to get our output. We would never have g of x equals x plus 5 and f of x equals x plus 5 in the same scenario because they have the same rule, right? We use a different label to tell us there's a different rule. So you are going to be responsible for writing some basic functions, basic equations, and function notation. Reminding you of a little bit of vocabulary. Remember that if you earn money, that's positive. If you pay out money, that's negative. Those are some of the things to think about. This example says Johnny triples his money by investing. We have to know that triples means multiplied by 3. If it says Johnny doubles his money, we have to know that that means multiplied by 2. If it means Johnny's money is cut in half, that means we have to know that that means divided by 2. Okay? I said that you're writing what I'm writing up here? Times 3 minus 2. And then when it says he pays $2 in capital gains taxes, that's subtract, right? You pay money out, you're subtracting if we're talking about this investment. So we're talking about how much money he's going to have after he invests a certain amount of money. He's going to triple the amount of money invested, but then he's going to pay a $2 fee. So times 3, that's then minus 2. Very important when you're looking at these kind of problems that you know what the variable is. So x is the amount of money that Johnny starts with. So his total investment is going to be the output, or the value of his investment is going to be the output. So f of x is going to be the money he earns, let's say. And that would be from this particular investment. So f of x, first thing we're going to do is we're going to start with x. Then we're going to multiply by 3, we said. And then we're going to subtract 2. So that we translate into a function, f of x. Remember, that's the money he earns on this investment. Where we multiply that money times 3 and subtract it, but we would not leave it in that ugly form. It's just 3 times the number of money amount he started with minus the $2. So if he started with $100, how much money would he make? So f of 100 would be 3 times 100 minus 2. So he would make $98 on that investment. Make sense? Okay. If you kind of think about the changes, you know, follow along? Okay, great. What does it mean to evaluate a function? That's all this slide says. Just need to plug in. So evaluating functions is the process of finding the output of the value of function for a given input. So to do this, all you're doing is you're taking whatever value they ask you and plugging it back in. So you're substituting the value they give you for your input and then simplifying. Evaluating is pretty captain obvious, unless you're freaked out because you're in the middle of a test and you realize you don't know what the word evaluating is. You don't know what that expression is. But that's all it means. When they give you an input, plug it in to get your output. That's all that means. So back here, we evaluated this function for a value for x of 100. So evaluate this function when x equals 100. That means you plug 100 in. That's all that means. Okay? Marissa, she earns $18 an hour tutoring at the community center, and on weekdays she is paid a bonus of $15 per shift. How much money would Marissa earn for working 6 hours on a Saturday? If x is the number of hours worked, solve the function f of x for x equals 6 hours. They could have also said evaluate the function f of x for x equals 6 hours. Those would be the same thing. So here she earns an hourly wage. She doesn't earn overtime like we've talked about overtime so far. We've talked about overtime as being a multiple of their normal wage. But here they just get a bonus, which could also be considered a version of overtime. Number of hours, and then they add $15 onto the end. So it's important that you remember what the X stands for. This is the input. And the output is how much money she earns on Saturday. So this f of x is how much money she earns on Saturday, 6 hours on Saturday. We're going to express this situation using function notation. And we're just going to use f of x. And where x is the number of hours, so she makes $18 times the number of hours she works. That part makes sense, right? But on Saturday and Sunday, she gets an extra $15. So for f of x is the money she makes on the weekend. So it's her wage on the weekend. Pretty bad handwriting. So money earned on weekend shifts. That's what we'll say. So now we wrote the function, and they asked us to solve it for when x equals 6. They could have said evaluate it for x equals 6. That just means we plug in 6. Everywhere there's an x, we put a 6. This is a label. This is telling us that we're plugging in 6 here. So f of 6, 18 times 6 is 108. We simplify that. When Marissa works 6 hours on Saturday, she earns $123. If it were Monday through Friday, she would not get that extra $15. It would be $108 only. I'll come back at the end if you're not quite finished. I want to make sure I get all the examples in. Domain and range. The domain and range is a limit on your inputs, the limit on your outputs. We almost always use X for our inputs and Y for our outputs, but we don't have to, remember, but we think of the domain of a function as the X's or the inputs, and the range of a function or an equation or the outputs. We're going to also put that number is f of x. So with the function notation, our output is actually the f of x. You see? So we're going to write a function. You got this? We're going to write a function, and then we're going to identify the limits on the inputs and the outputs. That means we're going to give the domain and the range. Armando works as a street sign advertiser for a local restaurant. I think that means he stands outside and spins a sign around and dances to try to call attention to this restaurant. So his job is to drum up business for the restaurant. So he only gets paid $10 a shift. So when he shows up for work, he's only guaranteed that $10. But for every person that comes to the restaurant, he gets determine the domain and range of the function and describes Armando's daily wages. So we need to figure out what is our input here. What is his salary or the money he makes per shift based on? Is it based on the number of hours he works? Not in his job, right? What's it based on? How many people go in that store? That's right. So the more people that go in that store, the more money he makes. So X is the number of customers that go in that store while he's on his shift for that restaurant. So he starts with $10, and it's 50 cents for every customer who comes in. So F of X, that's the money he makes on that shift. Each shift starts with $10, and they add 50 cents times the number of customers, and that's how his pay is computed. So the input is X, the number of customers. The output is how much they pay Armando. Number 2 says determine the lower and upper bounds of the domain. If no constraints are given by the problem, the solution is a set of all real numbers. That means you can put anything in. Right? Can we put any number into this function in this situation? We could plug any number in here, but when it fits this real world situation, right? Are there negative people? Are there half of people? No. Really what we're looking at is that. There are no negative input values, and they should be whole numbers. So if we're finding the lower bound, what is the smallest number you can put in? 0 is the smallest number. You can't go lower than that. Does it say, or is there any reason to think there would be an upper limit? There's an upper limit on the amount of money you can make as far as plugging into this function. There's not, right? They're going to let as many people come in that store as want to come in there. So the lower bound means there's no customers. No upper bound means there's no limit. The lower bound of the range and the upper bound of the range, the lower bound is for sure is always based on the lower bound of your inputs, right? So if our lowest bound is 0, we find our lowest range by plugging in 0 into our function. So when we have the lowest input, what is our lowest output? Well, if 0 people come in, there are no customers, he makes $10. Right? What is the upper bound? What's the upper bound of this function? Algebraically, it would be based on the number of customers, but it stops at $100, right? So we're going to put the upper bound because they're not going to pay any more than that. We can compute his hourly wage, his amount he makes up to $100 with this. If we plug in a number that puts it over $100, he still only gets paid $100. All the way up under Kylan, when you look under your desk, I think they captured something that makes it. Oh, your AirPods popped out. See it? I think I saw it. All right. So now they won't pay him any more than $100. Does not matter what you put in, so that is the upper bound. The last thing we're going to do is we have to be able to write in this inequality. So for the lower, for the domain, it starts at 0 and goes on forever, right? So that's just written as x is greater than or equal to 0. It has no limit on the other side. If it doesn't have a limit on one end or the other, if it doesn't have a limit on either end, the solution is all real numbers. That means that you can plug any number in. But if it only has a limit on one side, then we're going to have a regular inequality. It'll be less than or equal to 0, greater than or equal to 0, greater than 0, less than 0. But for our purposes, it can equal 0 or be greater, right? We do know they can't be part of equal. It's got to be a whole number, but we don't get too crazy about that. If we have two limits, like we do with the range, we have a lower bound and an upper bound. Start with the lower bound on the left, just like on a number line, the upper bound on the right. Your input or your output is always in the middle, and it's always less than or equal to. So what this says is his wage for this shift has got to be greater than or equal to 10, but less than or equal to 100. It's a little bit clearer there. I don't know. It's typed there in case you can't read my handwriting. These are the same things. So the domain can be represented with the inequality x is greater than or equal to 0, and the range, so that possible outputs would range from $10 all the way up to $100. Are going to have to be able to work with those inequalities and represent the domain and range that way. You can scan into your notes now if you like. Yes. Yes. I'm going back to example 1. If anybody needs me to go back to another one, let me know. There we go. Remember that there's testing in the morning for PM1. You guys aren't doing that testing. Fourth period starts after lunch tomorrow. Fourth period starts at 12:34. Okay, we're reviewing for our test tomorrow. We're reviewing for our test Wednesday, and then we're testing Thursday. One more time. You are allowed to use your notes on the test, but if you show up with that note, you still have to take the test. Are we clear? You may use them. You are not required to use them.